Hey guys, today we're gonna do the math questions for the periodic. So we'll start off with the grid. So the first question is, what's the limit of x as it approaches 16 in this function? So the problem here is that the denominator ends up being 0, which is not possible, so we can't just substitute it in. We need to try and get rid of it somehow. So we'll have to cancel it from the numerator, so we just expand it first. So difference of two squares, x plus 16 into x minus 16. Now we have to do something further because there's a root x here and 4. So as you can see, they're both roots of x and 16 respectively. So we further simplify it, so it becomes x plus 16 into root x plus 4 into root x minus 4 all over root x minus 4. And as you can see, it just cancels out with this. Now you just plug in 16, so this will be equal to 32 into root 16, which is 4 plus 4, so 32 into 8, which will be 256. So that is your answer, and this is the limit. That is a limit as well. So in the written, don't forget to put the limit as this limit symbol. Okay, next question. Okay, so for question 2, you have a trigonometric function which you cannot just substitute it, x equals to 0, as x tends to 0, because it's in the denominator and it will end up to 0. So you have to somehow cancel the sine 2x. So the most obvious way is to get somehow sine in the numerator, so you can just cancel it up and down. So you just distribute the 2 outside. Let me make that clearer. Okay, now remember, in written exams, always remember to put the limit if you haven't simplified it yet. Okay, so now what you need to do to get sine in the numerator is multiply up and down by 1 plus cosine squared. So you'll end up with 1 minus cosine squared, and that will become sine squared. And also, you can expand sine 2x as 2 sine x cosine x. It's an identity that we took last year. Okay, so now you'll end up with limit as x approaches 0 of 2 into sine squared x over 2 sine x cosine x 1 plus cosine x. So the sign here cancels, and this sign cancels, the 2 cancels, and the 2 cancels. So you'll end up with sine x over cosine x into 1 plus cosine x. So this is equal to 1, because it's equal to 0, because sine 0 is 0, over 1 into 1 plus 1. So the answer is 0. So now you have to check the options and see which one fits the description. So obviously number 6, and then you check these. So 2 over 1 plus cosine x, it doesn't correspond with any of the ones we have over here. So this is out. Cosine x over 1 plus cosine x, again it doesn't correspond, so cut that out. Sine x over cosine x into 1 plus cosine x, it matches this one over here, so that's why it's 1. So 1 and 6. Next question. Okay, so for question 3, again you cannot substitute because it ends up being dividing by 0, so you have to simplify somehow. So this is equal to limit as x approaches minus 5 of x plus 5 over root x plus 6 minus 1. So to get rid of this root radical, so you can start simplifying, you have to multiply by its conjugate, like the one we saw in the last question, which was cosine plus x, and multiply by root x plus 6 plus 1. So it ends up simplifying quite nicely. So x plus 5 into root x plus 6 plus 1 over root x plus 6 squared minus 1 squared. Difference of 2 squares. So as you can see, it ends up again simplifying into limit of x as it approaches minus 5 of x plus 5, because x plus 6 minus 1, so x plus 5, and then x plus 5 here as well. Should have put brackets, yeah, into root x plus 6 plus 1. So as you can see, the root x plus 5 cancels, and you end up with limit of root x plus 1, x plus 6 plus 1, as x approaches minus 5. And then you just substitute it in. It'll be root minus 5 plus 6, which is 1, plus 1, so it equals to 2. So then you go to your answer choices, and you see which one matches what you chose. Root x plus 5, no. Root x plus 6 minus 1, no. It's plus 1, as you can see over here. So 3 is the answer. And then when you substitute minus 5 in, you get 2. So it's 3 and 5. Okay, so for number 4, we have limit of x as it approaches 0 of 5 sine x plus sine 10x over 5x. So the obvious thing to do is to distribute it, because you have the trigonometric identity of this. on the board, written in blue. So you can just apply it anytime you have sine over denominator of x. Now, I'm not going to repeat the limit, but you certainly should do it for the written in your exams. And by that, I just mean writing limit. So the 5's cancel. So limit as x approaches 0. You no longer need to do that for that because it's 1. Plus limit as x approaches 0 of sine 10x over 5x. And then, as you can see from the identity over there, it's a over b, which is 10 over 5, which is 2. So it will be 1 plus 2, and that is 3. So that is the answer for 4. Now, next question. Okay, so question 5, limit of x as it approaches 0 of tan 18x over 8x. So we have to split tangent into sine over cosine. So it will be sine 18x over cosine 18x the whole thing over 8x, and obviously limit as x approaches 0. So cosine, we can take it down, so it will be lim as x approaches 0 of 1 over cosine 18x plus, multiplied by multiplied by sine 18x over 8x. So for cosine, you can just substitute in 0, so it's no problem. But for sine 18x over 8x, you cannot substitute 0 because the denominator will be 0 and you cannot divide by 0. So you have to use the sine rule of limit, where it will be a over b, as you can see above. So it will be 18 over 8. So this whole thing is equal to 18 over 8. However, in the question, they said put it in k over 4. So you just cancel by 2. So it's 4 here and 18 here. So the answer will be 9 over 4, and k is 9. So that's what you enter. Okay, so for number 6, there's an easy way to do it for multiple and typing. You just look at the slope of f of x, it's 5. So 5 into the change in x, which is delta, is equal to, or is at least less than, the change in y, which is epsilon. Now they gave you epsilon over here, which is 0.1. Okay, so delta is going to be less than 0.1 over 5, which makes it 1 over 50. And that is the maximum value that epsilon can be, is that delta can be. So over here, 1 over k is equal to 50. So for number 7, when you have these types of questions, without even looking at what they ask you to find, you immediately find out what's happening in between the junction. So at x, the junction is this one, when x is equal to -3. So when k plus x at -3 from the left, it's k minus 3. But -3 from the right, it is 4x squared, 4 times x squared, so 4 times -3 squared, so 4 times 9, which is 36. So basically what I did is I equated the left with the right. So k minus 3 equals 36, k equals 39. That's the answer. So for question 8, they gave you a graph and they ask you to find the limits. This one is very easy because you can actually see what's going on. So let's go one by one. So limit of x as it approaches 0 from the left, it's equal to 8 because this is the left. So this is correct. Now limit of x of 0, it doesn't say from left or right, which means it means of the graph itself. Now it's not continuous because as you can see it jumps up, so that's why there is no limit, so this one's wrong. Limit of x of 0 plus, which means from the right, which as you can see is 4, so it's allowed, it's correct. And limit of x does not exist. Yes, it doesn't exist because it's a jump. So 1, 3, 4. Now let's look at 5 and 6. Limit of x as from 0 minus, it does not exist, and 0 plus doesn't exist. This is false because there was a graph from the right and from the left. So the answer is just 1, 3, 4. Okay, so for question 9, it's about limit till infinity. Here is the rule for the limit to infinity. Here's the highest power is m of the numerator, highest power of the denominator is n. So when m is greater than n, it's infinity because the numerator becomes infinitely large compared to the denominator, and if m and n are equal, then it becomes a over b, and if m is less than n, it becomes 0. So the first one, they're equal, so a over b, so 3 over 1, so it's correct. Now second one, the numerator is greater, so it's infinity, which is correct, and it's plus infinity because 2 over 3 is numerator and denominator is positive. For number 3, the numerator is greater, but it's minus here, so that's why it becomes minus infinity and not even 0, so this is wrong. For number 4, it's the same, m and n, the largest power, it's 2 and 2, so it should be the coefficient, so 5 over 3, and it's not, so it's wrong. It says 6 over 7, so it's wrong. So no, for number 5, the denominator is greater than numerator, so it's correct, 0. And for number 6, the numerator is less than the denominator, so it should be 0, but it says 1/2, so it's wrong. So the answer is 1, 2, 5. Okay, so for number 10, it's very simple and easy, because they said the limit has to exist, the limit at 1, so over here. So for it to exist, the left limit must be equal to the right limit. So the right limit is 4, so what should be the left limit? The same thing, so 4. So function of g of x as it approaches -1 is equal to 4. So not the whole function must be 4, but the y value at 1 must be 4 from the left. And that is the 10th question.
Hey guys, so today I'll be helping you solve the math grid questions from question 11 till question 17. I accidentally wrote 10, but it's fine. So for question 11, we have to find out which of the following is true. So part 1 says that lim x goes to minus 2 minus is equal to f of minus 2. So for lim x goes to minus 2 minus, we have to substitute it into the first part of the function, which is x plus 1. We substitute minus 2 into it, so it becomes minus 2 plus 1, which is equal to minus 1. Same thing for f of minus 2, we just substitute it into the first part of the function, and we also get minus 2 plus 1, which is equal to minus 1. So minus 1 and minus 1 are equal to each other, so we know that lim x goes to minus 2 minus and f of minus 2 are also equal. Therefore, part 1 is true. Part 2 says that lim x goes to minus 2 plus f of x is equal to f of minus 2. This time, because x goes to something that's slightly greater than minus 2, we have to substitute it into the second part of the function, which is x plus 2. But for f of minus 2, we still have to substitute it into the first part of the function because x is equal to minus 2. So if we substitute minus 2 into x plus 2, we get lim x goes to minus 2 plus is equal to 0. Whereas if we substitute minus 2 into x plus 1, we get that f of minus 2 is equal to minus 1. But these two are not equal to each other. So we know that 2 is false. Part 3 says that f of x is right continuous at x equals minus 2. In this function, we know that it's right continuous when lim x goes to minus 2 plus is equal to f of minus 2. And as we saw in part 2, they are not actually equal, so that way we can know that it's not right continuous and that 3 is false. Part 4 says that f of x is left continuous at x equals to minus 2. That means that lim when x goes to minus 2 minus has to be equal to f of minus 2. And as we saw in part 1, they are equal, so we know that f of x is left continuous at x equals minus 2 and that 4 is true. Part 5 says that f of x is continuous at x equals to 2. For this function to be continuous, lim x goes to 2 minus has to be equal to lim x goes to 2 plus. And the function has to exist at x equals to 2. When x goes to 2 minus, it's slightly less than 2, so we have to substitute it into the second part of the function, which is x plus 2. If we substitute 2 into that, we get 2 plus 2, which is equal to 4. When x goes to 2 plus, it's slightly greater than 2, so we have to substitute it into the third part of the function, which is 2x. And if we substitute 2 into that, we get 2 times 2, which is equal to 4. So if 4 and 4 are equal, and the function does exist at x equals 2, as you see in the third part, we know that the function is continuous, which means that part 5 is true, and therefore part 6 is false. Question 12 also asks us to find out which of the following is true. But in question 12, we have a piecewise function. F of x equals to the absolute value of x minus 3. That means that when x is greater than 3, it's equal to x minus 3. And when x is less than 3, it's equal to the opposite of that, or minus x plus 3. And when x is equal to 3, we can put it in either one. Part 1 of the question says that f of 3 exists. All we have to do here is substitute 3 into the function, so we get 3 minus 3 is equal to 0. So we know that 1 is true. Part 2 says that lim when x goes to 3 plus f of x exists. All we have to do here is substitute 3 into the part of the function where x is greater than 3. So we put x minus 3 and we substitute 3 into that, so we get 3 minus 3, which is equal to 0. So part 2 is true. Part 3 says that lim when x goes to 3 minus does not exist. All we have to do here is substitute 3 into the part where x is less than 3, because 3 minus is slightly less than 3. We substitute 3 into minus x plus 3 and we get f of x is equal to 0. So the function does exist, which means that 3 is false. Part 4 says that lim when x goes to 3 f of x exists. What we have to do here is substitute 3 into x minus 3 and we get that f of x when x goes to 3 is equal to 0. So it does exist, so that means that 4 is true. Part 5 says that f of x is continuous at x equals to 3. For this to be true, the function needs to exist at x equals to 3. And lim x goes to 3 minus has to be equal to lim x goes to 3 plus. We see in part 2 and 3 they are both equal to 0, and so we know that they are equal to each other. And as we saw in part 1, f of 3 does exist, so we know that the function is continuous at x equals to 3, which means that 5 is true, but 6 is false, as 6 states that the function has removable discontinuity, yet we know that the function is continuous. Question 13 is also asking us to find out which is true and which is false. Part 1 says that f of minus 2 exists, and we can know that it exists as in the second part of the function we see that when x equals to minus 2, it's equal to 2x minus 2. And if we substitute minus 2, we get minus 4 minus 2, or simply minus 6. So part 1 is true. Part 2 says that f of x is not continuous at x equals minus 2 because it has a gap. For us to know whether that is true or not, we have to see lim x goes to minus 2 minus and lim x goes to minus 2 plus and compare if they're equal or not. For lim x goes to minus 2 minus, we have to substitute it into the first part of the function, or 3x, because it's slightly less than minus 2. And for lim x goes to minus 2 plus, we have to substitute it into the second part of the function because it's slightly greater than minus 2. For both x goes to minus 2 minus and x goes to minus 2 plus, we get minus 6. So they're equal. So there is no gap in the function, which means that 2 is false. Part 3 says that f of x is continuous at x equals minus 2 because f of minus 2 exists. But we know that that's not the only condition necessary for a function to be continuous, so we know that 3 is false. Part 4 says that f of x is not continuous at x equals minus 2 because it has a jump. However, as we saw in part 2, it does not have a gap or a jump, so we know that 4 is false. Part 5 says that limit of x when it goes to minus 2 of f of x exists. All we need to do here is substitute minus 2 into the second part of the function, and so we get minus 4 minus 2, or simply minus 6. And so it does exist, which means that 5 is true. Part 6 says that f of x is continuous at x equals minus 2 because f of minus 2 is equal to limit of x goes to minus 2 of f of x. So we know from the previous parts, part 1 and part 5, that they are actually true. And these are the conditions necessary to know if which the function f is continuous. So for this, we need to put that m is equal to x squared minus 36 over x minus 6. We factor x squared minus 36, so it becomes x minus 6 times x plus 6, and then we can cancel x minus 6 with x minus 6, so the remaining result is x plus 6 equals to m. Now we know that x equals 6, so 6 plus 6 is equal to m, so m is 12. Question 15 asks us to find the value of b, which makes g of x continuous. So, like what we did in question 14, we equate the two. So sine 12x over 3x is equal to b. As we learned before, sine x over x is equal to 1, so we want to make the denominator equal to 12x. We can do that by multiplying the numerator and the denominator by 4. So what we get is 4 sine 12x over 12x is equal to b. Sine 12x over 12x is equal to 1, so it becomes 4 times 1. And so we get that b is equal to 4. Question 16 asks us to find out how many points of discontinuity the function has. There are two ways of making a function discontinuous, either by making it undefined or by having a gap in the function. So if we look at the first part of the function, we get 3x over 2x plus 4 when x is less than 1. However, when x is equal to minus 2, the function becomes undefined. So x equals minus 2 is a point of discontinuity. And if we look at the second part of the function, we see minus 6x over x minus 3 when x is greater than 1. However, when x is equal to 3, the function becomes undefined, so we know that x equals to 3 is another point of discontinuity in the function. The other way we can find points of discontinuity is when there is a gap in the function. So when the limit of x goes to 1 minus and the limit of x goes to 1 plus are unequal, there is a discontinuity. So if we substitute 1 into the first part of the function, we get 3 into 2 plus 4, which is equal to half. However, if we substitute 1 into the second part of the function, we get minus 1 over minus 2, which is equal to 3. These 2 points are unequal, which means that we know that there's a jump in the function at that point. So in total, we have 3 points of discontinuity. One at x equals minus 2, one at x equals 1, and one at x equals to 3. Question 17 also asks us to find out how many points of discontinuity there are in the function. So if we look at x equals to 1, we see that when it approaches 1 minus, it goes to minus infinity, but when it approaches 1 plus, it goes to plus infinity. So we know that there's a discontinuity at that point. If we look at x equals to 2, we can see that as it approaches 2 minus, y is equal to 0, but when it approaches 2 plus, y is equal to 4. That means that there's a jump in the function at that point, which means that it's discontinuous at that point. If we look at x equals to 3, we can see that there's a dot that's empty in the middle. That means that there's a gap in the function at that point. So in total, there are 3 points of discontinuity. One at x equals to 1, one at x equals to 2, and one at x equals.
Start with section 1.1.3, which has to do with the absolute value inequalities. I'm currently doing example 1, and let's do it together. It asks the absolute value of x minus 5 is less than 1 minus 3x. What values of x satisfy this? So what I've done is I've split the absolute value into piecewise functions. So minus x minus 5 if x is less than 5, because when x is less than 5, you're going to get a negative number. But the negative becomes a positive because of the absolute value. So that's why I made it negative, so it becomes fully positive. Or x minus 5, x is greater than or equal to 5. Now I've put the equal here because somewhere has to be equal, and since 0 is neither negative or positive, it doesn't matter where you put it. So let's get solving. Now in the first one, the requirement we have is x has to be less than 5. So substituting this in our equation, we get minus x minus 5 is less than 1 minus 3x. Let's call this case 1. Right? Now it becomes minus x plus 5 less than 1 minus 3x. Take minus 3x here, you get 2x less than minus 4. You get x less than minus 2. Alright? And now since x is less than minus 2 satisfies a condition of x less than 5, we're totally fine. Now let's move on to the second case, case 2. Again, x minus 5 less than 1 minus 3x. You get minus 3x here. 4x less than 6. X is less than 3 over 2. But now since we have that x is greater than or equal to 5 and x is less than 3 over 2, they don't make sense. So this does not work. So the only way we can do is, the final answer is x has to be less than minus 2. Okay guys, let's go to section 2.2, which talks about the derivative. As you guys can see here, I've drawn a quick curve on the x and y axis. I've called this curve the f of x, and I've labeled 2 points, one in red and one in green. The one in red represents the point a comma f of a, and the point in green represents the curve a plus h and f of a plus h. Now if you were asked to find the slope of this, wouldn't we just do, let's call this x1, y1, x2, y2. Wouldn't we just do y2 minus y1 over x2 minus x1? We would do exactly that, right? So let's try to find that in terms of this f of a plus h minus f of a over a plus h minus a. A and a cancel out. And wait, this looks familiar. Isn't this the definition of the derivative? Let me phrase it more formally. Y prime equals limit as h tends to 0 f of a plus h minus f of h or f of a over h. So this shows us that the derivative, it basically is the more detailed form of the slope. But now since h is tending to 0, we should see h have very small values, 0.001, 0.0001, 0.10 zeros and 1. So h becomes smaller and smaller until we are at the same point itself. So the derivative shows us the instantaneous change of the slope, if you guys can understand what I'm trying to say. So now using this definition, let's have a quick application. You guys can do activity 1 number 1. I'll give you a few seconds to solve and then we'll check together. Okay, let's check it together quickly. F prime of x using the formula is equal to the limit as h tends to 0 f of a plus h minus f of a over h. You get x plus h squared minus x squared over h. You get x squared plus 2hx plus h squared minus x squared over h. X squares cancels. If we take the h out, we get this, this and this. Now since h tends to 0, it becomes 0. So the derivative is 2x. But that's not the full answer. They want the value of f prime of 4. Very easy. We just have to substitute. So f prime of 4 is equal to 2 times 4, which is 8. So you guys can check your answer and we'll move on to the next point. Now another thing we can get from the derivative, as we remember last year, if we can try to find the formulas of the normal and the tangent at the point. Now I won't be going into too much detail as we've done this many times throughout last year. All you have to do is derive the formula, substitute the x value of the point you're trying to find the slope for. The answer you get is the slope of the tangent, and if you do the negative reciprocal, so let's say I got 2 as my answer, if you do minus 1 over 2 negative reciprocal, then that's the slope of the normal, and then you just do y minus y0 equals m or slope x minus x0, and that's a very simple point. I think it should be a very easy one. And let's move on to our next point. Now moving on to our next point, left and right side derivatives. So now the left hand derivative, if I can just draw a point here, assuming this is our x-axis and our y-axis, and we have like this, let's say I have a point A. The left hand derivative would assume all values before A. So the derivative at exactly this point, you could say, around. And the right hand derivative would be after A, so around here. So the formulas are very similar to the main formula with just one change. So the left derivative, let me put this LD, is limit as h tends to 0 minus the left side of 0, again f of a plus h minus f of a over h, and the right hand derivative excuse me, is the limit as h tends to 0 plus f of a plus h minus f of a over h. Now we only have a derivative at the point A when the left hand derivative equals the right hand derivative. If they do not equal, then the derivative at x equals A does not exist. So the only time the derivative exists is when the left hand derivative equals the right hand derivative. Okay? Now we learned two, not exactly theorems, but statements that are very useful for us. The first one of the statement is, if a function, I'm just explaining them in simple English, is not the exact wording, is not continuous at a point, then it's not differentiable at the point. So this statement saves us a lot of time. You might be wondering why. For example, let's say they give us a function and they ask us to show it's not differentiable at x equals a. Well, rather than using this huge definition and using up a lot of time in an exam, if we can just somehow prove it is not continuous at that point, then it is definitely not differentiable at that point. And the second theorem or statement is, if a function is differentiable, then it's continuous at that point. Well, one more thing to be careful of, we cannot use the converse of any of these statements. So if a function is not differentiable, it's not necessary that it is not continuous. These statements only work in this particular order. They do not work in any other order. So if we say that if a function is continuous, it's differentiable, that's completely wrong. Only if it is differentiable can we say with confidence that it is continuous. Now, to see if you guys understood what I said, let's do a quick application with activity 3. I'll give you guys a few seconds. Okay, let's check it together. Activity 3 says, consider the function f of x equals 2x minus 1 if x is less than or equal to 2, x squared if x is greater than 2. Show that f is not differentiable at x equals 2. Now, many of you must have tried to find the left hand derivative and the right hand derivative and showed that they are not equal to prove that it is not differentiable. But just a few seconds ago, I had said, if it is not continuous at the point, it is not differentiable. So I'm going to use that statement and I'm going to say, let's find the limit as x goes to 2 minus of f of x. Well, that's this function right here, which gives us 2 times 2 minus 1, which is 3. And now let's find the limit as x tends to 2 plus of f of x, which is 2 squared, which is 4. Well, since these are not equal, then doesn't the limit as x goes to 2 of f of x not exist? Right? It doesn't exist. Well, then isn't it discontinuous at the point? right? We've got a jump discontinuity at the point. So we can just say, I'm not going to write the whole statement down. As f of x is not continuous at x equals 2, you can put in parenthesis there's a jump discontinuity, or the limit does not exist, comma space, it is not differentiable at x equals 2. We just stated the statement that we just learned. And now two more facts you guys need to know are vertical tangents and corner points. So vertical tangent exists when either a vertical tangent exists at x equals a if the derivative at y prime of a at either side, so either the left hand or the right hand side, approaches infinity. And the corner point is when the point itself is continuous but it is not differentiable. So f of x is continuous at x equals a but not differentiable at x equals a. In that scenario, we can say that a is a corner point, and that covers everything you need to know for derivatives. Thank you. I hope you understood.